between these two ranges. That means no matter what is the value of these two nodes, what would happen here? I have a V that is greater than beta. What does it mean? Hey everybody, welcome back to Farzin Academy YouTube channel in Artificial Intelligence course. Today, in the continue of the previous video, in the chapter of games and adversary searches, we want to talk about alpha-beta pruning. Actually, today we want to expand the content of the previous video, that was Minimax algorithm, by introducing a very powerful mechanism, that is alpha-beta pruning, to help us to optimize the Minimax algorithm, and we help this algorithm to check less number of nodes to perform its process. So I strongly recommend to you, if you haven't watched the previous video yet, go and watch that video that was about Minimax algorithm and basic Minimax algorithm, and then come here and watch this video, Alpha-Beta Pruning, because this is exactly the continue of the previous video, and you have to know how Minimax algorithm works to understand Alpha-Beta Pruning correctly. So because of that, I provide the link of the AI playlist in the description of the current video. So go to description, find the link, click on it, and all videos of the course will be shown for you, and you can find Minimax algorithm video. That would be video number 21, and watch that first, then come here and enjoy this video. And subscribing my channel, liking this video, sharing with your friends, and leaving a comment would be a very big help for me and my channel, and help us to grow. Thank you very much. Let's start this video. First of all, there are some terms that we must know what they mean. First of all is pruning. What does prune mean? I think you know that already. When you have a tree in your home and some branches and limbs become dried, you have to prune them to help the tree. And this is exactly what we do in trees and graphs, in artificial intelligence and algorithms, by eliminating branches that are not promising. We have a very, very important word and term here, that is promising, and we should know what does it mean. Promising means this branch would lead us into a result that would help us to find a solution. So when we say we find a branch that is not promising, that means if we continue that path, using the branch is not helpful for us. So it's better to eliminate that branch that is not promising. And we call this elimination process pruning. So in alpha-beta pruning, we want to find the branches in our game tree that are not promising and eliminate them. What is alpha-beta pruning? That is removing redundant branches based on the range of the best scores of two players so far. In the previous video, we found out there are two players, min player or minimizing player, and max player or maximizing player. Min player tries to minimize the score of the game, and max player tries to maximize it. So based on the best scores of these two players, we want to find redundant branches, the branches that are not promising, and remove them. That is we do in alpha-beta pruning. And the question is, what is alpha, what is beta? We save some values into these two variables that we will see. Alpha is the best score observed for the max player, and beta is the best score observed for the min player. So by knowing how alpha and beta works, we want to optimize the Minimax algorithm that I introduced in the previous video by adding these two values into the code and update it. So before seeing the code, I want to show a simple example in the graph so you would understand it better. Consider this game tree. Node A is of course a maximizing node because it's a blue triangle and its direction is on the up. And these three red nodes are minimizing nodes. So node B is minimizing, so it would choose the least value between its children. So one value is 3, so consider before seeing the values of remaining nodes. Node B, know that first of all, node A could be any value from negative infinity to positive infinity. Node B already has seen a value 3, so the value that finally node B would have is between negative infinity until 3. That means if other values of the remaining nodes are more than 3, finally B would choose 3. But if the values of remaining nodes are less than 3, node B would choose them. So the range that we set for these nodes so far is negative infinity until 3. So consider the next node is 12, so nothing changed. And the next node is 8, nothing changed. But we know node B is definitely going to choose value 3. So the range would be 3 until 3, that we can say just 3. And the node A is a maximizing node. So it already knows that node B has the value 3. So the value of node B would be 3 or something more. So we set the range 3 until positive infinity. So we have to wait and find out what would be values of node C and node D to set the definite value of node A. So we go to node C. Consider the first value of the first child of node C would be 2. So we say the range of node C would be between negative infinity until 2. And then we prune remaining nodes. You may ask why. See this. Node A would choose a value between 3 or more. So if your value is less than 3, there would be no difference for node A. And node C tells us that it would have a value between 2 or less than 2. So if I want to draw these ranges, consider we have this axis. Node A would have value 3 or more. Node C would have value of 2 or less than 2. So there is no common point between these two ranges. That means no matter what is the value of these two nodes, because node C is going to choose a value between 2 or less than 2. So consider these nodes are more than 2. There is no difference for node C. It would choose 2. And 2 is not in the range of this maximizing node. And if it's less than 2, so node C will be updated, but there is no difference for node A because it would choose node 3 that it has it already here. So this is how we want to optimize our Minimax algorithm to prevent checking nodes that would make no difference in the final result for our nodes in Minimax algorithm. So let's see the code right now. It's just like the code that we had in the previous video. If you haven't watched it, I recommend you to go and watch that first. We have 3 functions, alpha, beta, max value, and mean value. And before talking about alpha, beta, we have to see max value and mean value. In the previous video, we have max value and mean value too. Max value is for maximizing player, and mean value is for minimizing player. So the first line is just like before. We say if game is terminal, that is the current state is the final state, we return utility and null. But if there is not our terminal state and the game is still going on, we have to set value to negative infinity because we want to compare this value with our minimizing value for minimizing player. We compare them and update value. So because this value would be a positive number, we set it to a very, very low value that would be negative infinity. Then in a for loop, I say for a in-game.actions of a state. So I want to check all possible actions in my current state. So I save the value and action of the minimizing player because I want to predict the best action of my opponent, that would be the minimizing player, by calling the function min value. This function is here. And then I say if v2, that is the value of minimizing player, is more than my value, that its initial value is negative infinity, then I update my value and my move by setting them to v2 and a2. And then this is the point I set alpha. Alpha is the best score for maximizing players so far. Do you remember from our first slide? This is the best score observed for max players. So I say what would be the value of alpha? Alpha is the maximum of alpha and value. So I find the maximum of alpha and value and set it to alpha. That means we keep alpha until we find a value that is more than alpha. And when we can finally get out of this loop, we say, or better, when we can do a pruning in this loop, we say if value is more than or equal to beta, then return v and move. What does it mean? What does v is greater than or equal to beta? It means we have a value that is better than the best score, or we have to say that our minimizing player has a score that is better than our value, so we can prune that. And similarly, we have this line in minimizing player. We say if v, or our value, is less than or equal to alpha, that means our maximizing player already has a better score than our value, so we can prune this branch. And everything else is just like max value function, unless we set value for min value to positive infinity, because the score of minimizing player is always negative. And finally, based on our agent is maximizing player or minimizing player, we set value to one of the max value and min value functions to our value and move in alpha beta function, and we return the move to find out the best possible move in the game. Let's see an example to find out how this alpha beta pruning works in Minimax algorithm. Consider we want to apply the Minimax algorithm with alpha beta pruning in the following games. So we have this game tree with minimizing and maximizing nodes and some values that I set for leaves of the tree. So first of all, each node has three numbers or three parameters, value, alpha, and beta. And we want to one by one find these values and set them to their parameter. So consider I want to start from this node. I say for this leaf that is 4, my value will become to 4. And because this is a max node, I set alpha to 4 too. And after that, I have to check my second child of this node, that would be 8. And if you remember, here I have to do this process. Alpha is equal to maximum of alpha and value. So our value is 8 here. So I can update these parameters and set alpha and value to 8 because I have a new node. After that, I have to go for its father. That would be a min node. So I say because my max node is 8 and 8 for value in alpha, I set value in beta for minimizing node, that is the parent of my max player, to 8 and 8. So after that, I would go for another max player, that would be this node, and because of this leaf with value of 9, I set v to 9, and I set the beta of this node to its father. So its father beta is 8, so I set this beta to 8 too. And what would happen here? I have a v that is greater than beta. What does it mean? Let's go back to our code. We say if a v is greater than or equal to beta, then return. That means then is the point you can perform pruning for maximizing nodes. So is your node maximizing? I say yes. V is 9, beta is 8, and this is a maximizing node. So this is, I can perform pruning for remaining nodes. And I have just one remaining node, so I have to prune this branch that you can see here. So I prune that. So let's go further. I set value in alpha for my max node here to 8 and 8 because of this mean node has the value of 8. So after that, I go for all remaining nodes on the right side, and because the alpha of this node is 8, I put all alphas on the right side to 8 too. So as you can see, we have 3 alphas assigned to 8 on the right side of the tree. And after that, I go for this node. I say I see this value, so I set it to 2. And I go for its parent. That would be this min node. I set its value to 2 too because it's seeing this value here. And the point is, right now, I have a min node that its alpha is greater than its value. What does it mean? Let's get back to our code again. We say for mean value, if v, our value, is equal or less than alpha, then return or then prune. So let's get back to it again. I have v assigned to 2 and alpha to 8. My alpha is greater than my value. So this is where I can prune remaining nodes. So I can prune this branch and I don't have to consider all these nodes. So as you can see, the optimization that we just have done on this graph helps us to prevent checking 1, 2, 3, and 4 nodes just using alpha-beta pruning mechanism. This is very beautiful and very important. Your professor in AI course gonna make some questions of this subject for you. Don't doubt. So this is the end of this video. If it was useful for you, it would be a big help for me and my channel to subscribe my channel, like this video, share it with your friends who are interested in artificial intelligence and computer science, leave a comment, and that's it. Support me. Thank you very much. See you later.